In this video, we are going to go over what's known as a global optimization example. I'm going to show you every step you need to take in order to set this up for Nastran Solution 200. Now, this is the example we're going to be working with. The first thing you'll notice is that there are two maximums here, maximum 1 and maximum 2. The global maximum, if you will, is this peak with the value of 1.5, comma 1.5, and a z-value of 2.01. What optimizers usually do, they find what are known as local minimas and maximas. So here, for example, if I was just performing one local optimization, depending on where you start, you might just find what's known as a local maximum here, since we're using this example. The unfortunate result of local optimizations is that you can miss a better maximum in this case. It doesn't only have to be a maximum, it could be a minimum too. So here, if I flip this function, you can see that, well, if I can flip it, well, I guess I can't flip it. Here, let me take a step back and say that with one single local optimization, you can completely miss a better solution to your optimization. So in this video, I'm going to set this example up. I'm going to first perform a local optimization, and then I'm going to show you the magic option to trigger global optimization. What global optimization ends up doing is it will start at multiple points. So hopefully here, and it's clear in the video, you can see all these dots. The optimizer will start at multiple starting points, and it will perform multiple local optimizations. So here it's going to start at point 1, at point 2, point 3, and 4, depending on what the number you set as a default. It will then perform local optimizations, and then out of the best optimum solution, it will decide that as the global maximum or minimum. So let's go ahead and set up first a local optimization example. So let's go ahead and first go to the size web app, and then we will go ahead and select our starting BDF file. The steps here are very applicable to general examples. I like to start off with very simple examples just because they communicate the concepts very easily. So let's go ahead and create our x1 and x2 design variables. So here I'll go ahead and select these two properties. And then after that, I'll go ahead and select the stir property. Let's go ahead and focus on selecting an objective now. This is a very explicit objective, so let's go ahead and take a few moments to properly type it in. So here the objective is e to the -1. I think I might just be able to use the negative symbol. Let me zoom in so you can see what I'm typing. So x1 squared plus x2 squared close. Let's close this, plus 2.0 times exp. And here what it's saying is that there is a negative term. And then here we have x1 minus 1.5 squared plus x2 minus 1.5 squared, and then we'll close all of this. And then we want to find the maximum, so we'll go ahead and set this as maximum. And here, let's go ahead and quickly inspect where the problem is in the expression. So let's see if we can spot what happened here. E to the negative x1 plus x2 squared plus 2e to the negative x1. And here I think it might be a term here. So this should be like that's the first error I caught. Oh, so it was an issue with the parentheses. Okay, now again, let's go ahead and set this as the max. Let's go back and download this example. So I think you've seen some of my videos before. Let's go ahead and perform the optimization. So the first local optimization is starting at a point -1, -1. So let's go ahead and look at the graph here. -1. So that would be this orange point. So here, let's look at the z value, 0.135. I want to know what that value is because it will help me confirm I've typed in the equation properly. So here you can see the first objective value is 0.135. Since this matches the value on the graph, I have the confidence that I typed in the equation properly. Now let's go ahead and see what the local optimization looked like. So here we see that the local maximum was found to be, and here I have to play with the graph again. It might be worth closing some of these things. So here at a point almost at the global maximum, we have a -0.0125 and 1. Let's go ahead and see what we got at the end. So here we have 1.025, and our design variables, they were 0.04, 0.04. I believe that is exactly what we have here. So here 0.0375 for both x1 and x2, and then 1.02. So more or less we have the same values. Now, we know for a fact that there is actually another maximum to this equation, or this problem, and it's actually the global maximum for this space. It's here at I believe 1.5, 1.5 at a z value of 2. So how do we obtain this with Nastran solution 200? How do we obtain the global maximum? How do we obtain the global optimum? So it's very easy. If you go back to the web app, go under settings, there is one checkbox, just mark that as global optimization. Go back to the exporter. Always be aware of any error messages that you get here. So here I'm getting an error message that the variables are now incomplete. So let's go ahead and jump to the design variables and see what is happening. Here you can see that the status is now red, meaning that there is an incomplete entry defined. So let's go ahead and see what is incomplete about it. So here I can see that the lower and the upper bound are not complete. So this is where I have to type in the values. So here, let's go ahead and say that the lower and upper bound are -5 and 5 respectively. And here, I'll just type in 5 there. Now, if I go back to the exporter, that message is gone now. So let's go ahead and download this new zip file. One important thing that you should do when you're using global optimization, make sure that there are no spaces, there are no odd characters in the folder name or the path. This is a special process that requires this special attention. Again, make sure that the folder name and path name are free of spaces and special characters. If this is your first time using global optimization, you might get a few prompts to enable remote bootstrap. Just simply say allow access. You might get asked to allow multi-op.exe to have access, just allow it. So here you can see that Nastran is not performing the local optimizations. Here it's use sample 0, 1, and 8. Each sample here is corresponding to a line that represents the local optimization. So here, multiple local optimizations will be performed at different starting points. Once it's complete, it will find the best out of all the local optimizations. The best will be taken as the global optimization. So here you can see on the status page, it's going through each one by one. So here, let's go ahead and give it a few moments while it's completing itself. And here is the final result of the global optimization. You won't see each line plotted for you. Instead, you have the last, or rather the local maximum for each sample. So here, what you're seeing in terms of the bar graphs, you're seeing the maximums here. So here for local search 1, that would be this one. The maximum was 2. For this other local optimization, you can see that the maximum was 0, I believe. So now let's go ahead and take a look at what we have here. So here we see that we have sample 1 and sample 5 have a global maximum of 2. Sample 0, 2, 3, 4, 6, 7, and 8. These all have for the most part, global maximums of 1.025. If I isolate these and I just show those, you see that the design variables are almost all the same. So here, this is telling me that the global optimum has converged to this single point for samples 0, 3, and 4. Now let's go ahead and see what the other ones are. So here we see that sample 1 and 5 are landing at a value of 2 and 2. If we look at the design variables, we see that they are both the same. And this makes sense. Although not plotted here, there was another local search here. Imagine that there's another local optimization that lands in the same exact spot. Here you can see that both of those searches land at the same exact spot. So this is the most high maximum. So according to this file here, we see that it says the global solution is local optimization sample number 5. The objective is at a maximum of 2.01. And there you have it. That's how you're performing global optimization. You can see that it wasn't any harder than just performing a normal local optimization. Just go to settings, mark the checkbox, ensure your variables have the necessary lower and upper bounds, and then let the web app do its thing. And then before you know it, you have results plotted. So if you have any questions, comments, you can send me an email, or you can leave me a comment in the video description or the video comment section below. Thank you for watching.